Hello all. Today we have day 2 of network security, and here we have the today's agenda, which is somewhat like this agenda provides a balanced mix of theory, practical applications, and hands-on experience gain both the knowledge and practical skills in network security. We will discuss about network security, business continuity, and lot more here in today's session. Then day 2 is filled with live examples of network security. And we are going to focus on individual domain. Just yesterday, we had a word about this particular domain on which we are going to work. Right. So I would like to tell about the network security a little bit. This is the another domain in the field of cybersecurity, or you can say information security, right? Large organizations, small organizations, and medium organizations we talked about in yesterday's day 1, right? Cybersecurity bootcamp day 1. Now, if I talk about the network security, the particular domain, then the large organizations have the dedicated team of network security in their large environment, right? Because they have dedicated budget for security and they have a dedicated team, the skilled team they are already hiring, right? So that is totally depend on what type of things large organizations are doing. Okay. If I talk about the medium scale organizations, then they are also hiring the skilled person for network security. But I don't think so that they are working as an individual for network security team and security team, right? Then server management team. This is not a case. And if I talk about the small organizations, then this is the case is like small organizations are not really much working on these particular domain sites. They do not have the dedicated domains either, right? So if I talk about the medium organizations and the large organizations, then they are already using the network security as a dedicated team, right? If I move ahead, then here you will be able to see what is network security. This question arises as we already know that we are already working on an understanding on day 2, which is a network security. Now the question arises what exactly a network security is. This is for those who are new to the domain, the cyber security domain, and those who are really new in the network security domain, right? So network security refers to the practice, policies, and technologies designed to protect computer network from unauthorized access, misuse, malfunction, modification, distraction, or improper disclosure, right? Now, the thing is, they are aiming to ensure the confidentiality, integrity, and availability, which we just talked about in last class, the day 1 bootcamp. Okay, then the data it is transferred or transmitted and received across the network. Whatever the data we are sending, whatever the data the servers are receiving, the data the servers are sending, the data we are receiving in our PC or the endpoints, I can say in a general term, in a security term, then this is called an communication, and this is where we are providing the security to our networks, right? Now network security applies on various tools. If I talk about that, firewall is one of the core component in network security. It plays an important role. Now if I talk about the firewall, then firewall has their own components itself, just like WAF, which is web application firewalls, next gen firewalls, which we are using, where we are creating the policies, where we are creating the rules. Okay, they're also giving us the detections and all. These are the example of firewall, right? Web application firewall plays an important role to protect the threats against web applications, whatever the threats are going on against the web applications, right? If I talk about next gen firewall, then there is a different category of firewall which is giving you the security for internal threats, means organizational internal threats. Right now, one more category is there, which is packet filtering firewall. They are just watching out the traffic. Okay, whatever the traffic is coming inside, whatever the traffic is going out, they are just watching out the packets. In last class we talked about what packets exactly is, but in today's class we will work more deep into the packets, what packets exactly are, network packets. Okay, so they are only watching the packets, what type of packets are coming inside or going outside really on the traffic, and what is there inside those packets. Okay, so that is called packet filtering firewalls. Right. But if I talk about medium and large organizations, they are just using the next gen firewalls, where nowadays the AI is also enabled in those firewalls. Okay. Now, if I talk about IDS and IPS, IDS is like intrusion detection system, and IPS is just another prevention system, and the entity of an IDS. So we call it as IDS and IPS, intrusion detection system and intrusion prevention system. Detection system, we by the name we can only get like this is a detection system. Okay, this is just detecting what type of threats or intrusions are going inside and are coming inside and going outside. Right, they are not just preventing it, they are not taking any type of things, right? So that is why we call them as intrusion detection systems, the IDS. Right, then if I talk about IPS, right, then there is a functionality, the different functionality of an IPS, right, which means intrusion prevention system. Intrusion prevention system is like, this is preventing the threats which are coming inside and going outside, which means into any of the organizations if I talk about, right? Then they're monitoring into the networks, okay, networks of any organization where we have deployed the IDS and IPS. The simple example of IDS and IPS is the SNOR tool. We call it in a general term is Snobby. Okay, so Snobby is a IDS and IPS tool, right? So it is monitoring each every traffic, whatever is coming into the network or going outside, right? So detection means it is only providing you the detections and giving the detections into your SIEM tool, whatever the SIEM tools we are using. In coming session, we will also understand what exact SIEM tool is. Okay. Then the prevention system is providing the prevention to the threats, network threats, right? It is preventing all the threat on the basis of policies and rules, whatever the things we have created over tool, the Snorby tool for an example. Okay. Then we are also familiar with the encryption. What encryption is, yesterday we talked about. This is like encryption is like we are providing a different name, some name systems, or I can say the different type of what to say, encryption. We are providing the symbolic characters, the numeric characters we are providing to those data which are in a readable format. Okay, so that is called encryption. Authentication and authorization works under the authentication, which means where you are trying to log in. Authentication means your username and ID, username, ID, password. This is your authentication. Now, authorization depends on whether you are really a user on that particular organization or not, or you are really an employee. If you are an employee, then your authentications are working. Do you have username, ID, or password, right? Then this is called authentication and authorization, right? This totally depends on who is authorized to access these particular application from internal networks. Okay, not from outside network, from internal. So they will authorize you whether you are the employee or whether you are connected from the internal servers or not, right? Then we call it as VPN, virtual private network. So virtual private network is really working on IPE version 2. This is a protocol on which VPNs are working, and they are using a protocol as IP security, which we call it as IPsec, IP security. Okay, so we already know that VPNs are more sustainable, right? Most of the companies are using secure VPNs, at scale VPN. These type of VPNs they are using, and some VPNs we have a free, which we are using on our mobile phones and PC, right? So that is somewhat like the Thunder VPN. If we have, then we are using those Thunder VPN as a free VPN tool. so that we can access those particular applications or websites which is blocked in our country or in our area, right? So VPN is providing a secure tunneling. This is the functionality of VPN. They are providing secure tunneling, so nobody from outside can really see what exactly you are searching and what exact data you are sending to different servers, right? Yesterday we talked about MITM, man in the middle attack, right? So we can counter the man in the middle attack with the help of the VPNs or proxy we are using, right? Because they are providing a tunneling solution with complete encryption, right? Then there are SIM tools and backup and recovery. If we are doing backups, frequent backups on 3 months, 6 months, 1 year, or every month, or we are performing the recovery of data in our environment, then we also need VPNs, we also need proxies, we also need encryption. Okay, we need firewalls over there, we need intrusion detection system. So the communication will be secure if we are working on backup and recovery part, right? So most of the organizations right now are working on backups and recovery to mitigate or to protect their data from ransomware, right? So that is why they are creating multiple copies over the network or over the database systems, right? So this is what network security is. Now here on your screens, I am presenting the network architecture and protocols. Network architectures basically is like network architecture and protocol are fundamental concepts, right? Which means this is a basic concept on which we are working on network security, right? How our devices will be present inside a network, okay? Which type of topologies, which type of devices, right? Which type of models we will be able to use in our network or in our infrastructure if we are deploying those. Okay, the large organizations and the medium organizations are based on these type of architectures. Okay, and if I talk about small organizations, then all small organizations are also reliable on these particular models because they are deploying so. Okay, so this is what network security and protocols are, and they transmit efficiently and accurately between all the devices if they what all the devices they have inside the network. All right, then whatever the devices we have inside the network, so we are providing the security all those devices as well, plus the traffic which is coming inside and going outside. Okay, so every network architecture, the network architect will design, they will see how the data will come inside the infrastructure or to the endpoints or the endpoints we have deployed, right? And how they will communicate securely. So this is the duty of network architects, how they are designing the network, right? Now, if I talk about network devices, the network devices are same IDS and IPS we have, firewall, the physical firewall systems we have, right? Then we have the other devices like proxies. Okay, we have the proxies of as a network device. Okay, so they are looking into all the traffics. Now, if I talk about the network types, so this is very much simple that what type of network types we have. Hope you have seen this LAN, WAN, MAN. Right. This is a very common term that we are using. We have Wi-Fi routers in our home, right? So they are using a LAN connection, which stands for local area network. Okay. So a local area network connects devices within a limited area. Okay, small area if I talk about, such as home, right, office or campus, a small campus in the sense college campus, school campus, whatever it is, right? It is typically used to share resources like files, printers, and internet access, providing to the students. Students can easily access the printers, student can easily access the files, right? So this is useful for limited area, or I can say the small area, local area network. Okay, this is one of the network type. Now the example is office network with computers connected to a central server. There is a server which a college or office campus has deployed. They have their own server, which we say it as on-prem servers. Okay. Now that particular on-prem servers are connected with different type of devices. Okay. Now different type of devices are using some type of internet, so you can access those internet, you can access those devices whenever you are going to your computer labs. You guys are in college, okay, whenever you are going to your computer labs, right? So how your internet is working, how your computer labs are working, how your endpoints, mean computers are really connected, right? So if you are sharing anything over the network, so every who has access or who has the access to the internal network, they can easily access those files which you have shared, right? So this is very much simple. At home, we can also do same job, okay, where the multiple devices are connected to a single router, right? Then that technology which they are using is Ethernet cable. We already seen that wired or wireless in the sense router or uh, access point. Okay, these are the technologies which we are using for LAN, area network. Then if I talk about MAN, which is Metropolitan Area Network, this uses a larger geographic area than the LAN. LAN is small and MAN uses large geographical area, typically spanning a city or a place, right? The large campus, okay, campus 1, campus 2, campus 3, they are all connected with MAN. So they are using MAN technology, Metropolitan Area Network. It is used to connect multiple local area networks within a metropolitan area. So we are creating small LAN networks. So it become a MAN, metropolitan network, if we are combining all of those, right? Example is a university network connecting various campus within a city, or a wide Wi-Fi network. Now, if I'm sharing this, now if you are able to see it, I would like to show you the exact diagram how MAN is exactly working. Okay, so suppose this is your campus, okay, the college campus, or you can say the office campus, whatever the thing is, right? So here is one single server is deployed, right? And you are using a LAN, the small network, which is LAN, LAN, right? Okay, so now these servers on the basis of these LANs are connected with multiple office campuses or the college campuses, if I say. So this server is again connected with the LAN. Okay, so according to the LAN, this server has the remote access. Okay, and they are communicating with each other, right? So this will become a wide area network. Okay, the more metropolitan area network. So multiple geographically, graphically, right? So this is the exact architecture how they are exactly communicating with the help of LAN, and they are creating the metropolitan area network, a wide range, right? Then if I talk about the wide range of network, which means wide area network, okay, we call it as WAN. A WAN covers a broad geographical area, often extended across cities, countries, or even uh, which means like countries, places, cities. Okay, we are accessing the internet. So if you see, like, we can also connect or communicate with the different geolocation servers as well, right? So if you are using any IP, the VPN is using those IP. So how your VPN traffic is traveling again and again, right? So this is called wide area network, which they are using. So this is also created by the metropolitan area network. Then metropolitan area network is just connected with the other servers and server. This is one MAN. Okay, this is one MAN. Okay, metropolitan area network. Then there are some different type of servers at different location. Again, right, in the single country. This is one country. Okay, a single country. Then this servers really connected with the another MAN solution. Okay, metropolitan area network. Then they are communicating with the different countries and all. Okay, they are connected with the small LANs, then MANs. Then again they are creating the wide area network to come to connect with multiple LANs and MANs connections. Okay, then they are sending it to the different countries. Okay, so hopefully you guys have heard about the submarine cables. Okay, submarine cables are into the ocean. Okay, and those locations, so communicating with the or communicating with the different countries or different places. These are the submarine cables. Okay, if you do not know, then you can search on YouTube or you can search on Google. So you will identify that how these submarines cables have been working with wide area networks, and these are useful to create one communication to another communication widely or internationally, country wise, right, city wise, you can say. Right, so this is how communication is going on inside the network. This is a basic fundamental or architecture or protocol, you can say, that we are using. Okay, then one more thing is there, which is like campus area network, CAN. Okay, this is like a CAN is larger than a LAN, but smaller than a MAN. This is somewhere in between of LAN and MAN. Okay, typically covered a college campus or a business park. It connects multiple buildings within a specific area. Suppose you have a building, right? Now you have means a single building and they have different towers. This is tower one. Okay, so this is tower one. Then I can say this is tower two. Okay, so here we can apply the CAN to communicate from this tower to this tower, where we can say it as CAN, campus area network. Okay, typically covering a college campus or a business park. Okay, or every business park or the towers, those who are present into that particular place, right? The corporate park, we can say. So they are really interconnected with single internet, and they are using a technology called CAN, campus area network. Okay, then example is a university network connecting all academic and administrative building in one campus, just like you have CS building, right? Then IT building, then management building. So those are using campus area network within a single premises if they have, right? So this was the network type, right? Now we have layered models as well. So layered models is very much interesting in network. You can say that the networks are really dependent, or the communications are really dependent on layered models, right? The layered models is like the OSI model and the TCP model. Okay, how these systems inside a network are communicating with each other. Okay, so they are applying a OSI model, which means International Organization for Standardization. Okay, this is developed by International Organization for Standardization, which is ISO. Okay, then it has 7 layers, if I say, which is physical layer. The first one is physical layer, right? Then we have data link layer. Then we have network layer, the third one. Then we have transport layer. Then we have session layer, presentation layer, and this one is application layer. All right. Let's talk about the layer one, which is a physical layer inside OSI model. Okay, which defines the physical medium for data transmission. Okay, including cables, switches, electrical signal, or optical pulses. Okay, this is the function of physical layer, right? Where you can identify that the physical form of data to be transferred from with the help of cables, right? The switches we have, the routers we have, for an example, the router. So this is a physical layer which we can really touch. Okay, touch the network device, you can say, or the physical firewall if we have deployed any such type of devices in our network, right? Then data link layer is basically works on handles the physical addressing, error detection, and connection on which the MAC addresses are working, which is called data link layer. Over a data link layer, the MAC addresses are working for communication, right? The MAC address, we also call it as a physical address. Okay, the MAC address, second name is physical address, or IP address, second name is logical address. Okay, then Ethernet cables are also working. Then point-to-point protocols or switches are also working for a data link layer, right? Then we have network layer. Network layer manages the logical addressing and routing of data across different networks if we have, right? So it will connect different type of devices with different type of networks. Okay, that is we call it as network layer, which is a third layer. Okay, It determines the best path for data to travel. I can show you how they are exactly working. Yeah. So this one is one. Okay. So they are identifying the best route to identify to send the data really very fast. Okay. So this is a network layer. Suppose this is one device. Okay. This is second device. This is third device. Okay. And this is fourth device. I can name those one, two, and one device is this. Okay. One, two, three, four, and five. Now this needs to identify, this wants to send a data or a traffic or a packet, you can say, to one of the system, which is this system. System 1 wants to send data to system 3. Okay. Then how it will apply our shortest path to be in. Okay. So they will apply as from which it will gather the data in between. So I can mark it as 6th and the 7th computer as well. 7 computers, there is no problem. So which is the shortest path the network layer will use, and they will automatically identify all of them. So I can say that computer 1 wants to send the data towards computer 3, then they will simply use this path. 1 will transfer the data to computer number 5, then computer number 5 will transfer the data to computer number 3. If they are using these particular route, then there will be a delay inside the communication, and there will be lots of endpoints which are there to submit the data or transfer the data. Okay. So this can cause, then in network layer, we can say the IP addresses are working, routers are working, or internet control message protocols are working, which we simply call it as ICMP, on the basis of which the ping. Yesterday we learned about the ping command. So the ping is working on echo. So IP echo, and this is how they are receiving the data whenever you are pinging one of the devices or DNS. Right. Let's get back to the same one. Then we have layer number 4, which is ensures end-to-end communication, reliability, and flow control. Okay, it segments and resembles data and provide error recovery, on which the TCP/IP protocol or UDP/IP protocols are working. Okay, so we will understand TCP/IP protocol and UDP into the network protocols, right? Then we have session layer. Session layer is like you have already heard about, you whenever you are logging to one of the servers and you are mentioning your username, ID, or password. So it will create a session, or you have logged into your banking websites. Okay, so you are providing your username, ID, and password. Okay, so they are creating the session for you for a limited time period. Okay, so that is working on session layer. They are creating a session for a limited time period, right? So it handles the establishment, it handles the maintenance and transmission of connections between one device to another, or bit applications as well, right? So the example is NetBIOS protocols or remote procedure call, which is RPC, remote procedure call, to connect with the remote servers. Okay, and the services they can call. On the basis of that, the session layer is working to establish the session so that you can simply work on. Once the session has been expired, so you will be logged out. Okay, so who is handling this? The session layer, the layer 5 is handling. Presentation layer is like translation data between the application layer and the network format. It handles the data encoding, encryption, compression, everything over the presentation layer. Just like you can see, like how I am presenting the data, I am using one of the application, or I am using one of the web applications. Okay, you are using YouTube to watch this stream, right? So that is an application layer who is fetching the data and showing you over your screens. So that is called presentation layer. Okay, or you are using any websites, right? So that is again a presentation layer. They are using some type of encryptions to use to transfer data from one medium to another. Then we have application layer. which provides the network services directly to end applications. Okay. Then it facilitates application level protocol and interfaces, which right now we are using as a communication. Okay. Which is a best example is like HTTP protocol, which is hypertext transfer protocol using port number 80. The communication which is going on, that is totally not that much encrypted, but this is based on the certificates, and we are using those applications, the websites, if we are accessing those, right? So that is called application layer, right? So that was the layered models. Now we will talk about network topologies. Okay. Network topologies is like the architecture, what type of architecture we are following, and on the basis of which model. Which model means small organization, medium organization, and large organization, right? So on your screens there, the diagram is already present. Okay, so this is a bus topology. We call it as bus topology. So how the devices have been connected with single wire. Okay, and all the devices are connected with a single wire. This one, the medium wire. Okay, so if a single computer stops working, okay, then another computers, those who are connected in the bus topology, they will be able to gather, or they will be able to get any type of data from single computer to any other computer, which is simply means the if single computer goes down, then other computers won't be able to communicate further. Okay, the drawback of bus topology, but there is an advantage is like they will transmit all the data, all the traffics really very fast. Okay, so they are dependent on Ethernet cable, or this is a backbone topology which we are using in small organization, because if we are deploying this bus topology, this is really cost effective for us. Okay. Then there is a ring topology. If I say that this is the ring topology, you can say, right? This is connected with the hubs. Okay, so hub will be able to communicate over all the devices which are present. But the thing is, there is a disadvantage of this ring topology, which is like if this device, the device number 1, is trying to send data to device number 4. Okay, so this cannot send data to this one anti-clockwise, right? So this has to go to device number 2, then it will go to device number 3, then it will go to device number 4. This is the exact or same route it will follow again and again. Now if device number 2 wants to send data or communicate with this device number 1, so it will send data in a way device number 3, 4, and 1. Okay, so this is the disadvantage of this topology. If one device goes down again, then they won't be able to communicate. They will be up, but they won't be able to communicate with device 1, whereas device 2 can still communicate with device number 4 and device number 3. Okay, so this is ring topology. They are connected with the hub. Now if I talk about star topology, so these devices are connected with in this format, star format. The hub is present, the switch is present between the star topology. So star topology is very much reliable to communicate for different type of data and different type of devices within the small, large, or medium organizations, right? If one device goes down, then there is no problem, they will still go on. Okay, and they will identify a shortest route to transfer the data into the star topology. So these are the topologies which we have for communication. One more topology is there, which is somewhat like a mesh topology. Okay, so we are using a mesh topology as well. I can show you that what exactly a mesh topology is. So this is one device, this is second device, third device, okay, the fourth device, fifth device, sixth device, right? Seventh device, eighth device, ninth, that is 10, 11. Okay, if I say these are the 11 devices which are there into mesh topologies. Okay, so all these devices which are there are connected with each other, directly connected with each other, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so one device is connected with 5, one device is connected with 6. This is our 10, 11, 12, this, this, and this is how now this all these devices are connected with each other. So they are not creating such type of architecture, a great architecture. Okay, and this is how they are connected with each other. If I say, then this one is connected with this one is connected with this, right? And this is how they are connected with each other, right? So this is a mesh topology. So this is not a cost effective architecture, if I say, because most of the wires or most of the uh, functions you are using over there, and device won't be able to understand where I need to send the exact data. So we are not using the mesh topology, but yes, and also this is also not a cost effective to deploy, and also the maintenance is higher than the other topology. So this is the drawback of mesh topologies. Okay, basically this is not again a topology we can the organizations are using. So this was the network topologies. Okay, now we have network protocols TCP and UDP. If I talk about difference between TCP and UDP, which is somewhat like transmission control protocol, and the UDP is like user data protocol. Okay, TCP is more reliable, okay, to communicate with any of the devices. If I say that you are using WhatsApp, okay, and you are sending the message to your friend or somebody, okay, over the WhatsApp. Now the WhatsApp is using the TCP communication. Why? Because whenever you are sending the data over, I can say that this is a data in a computer format, but you are sending the message to somebody over the WhatsApp. And if it is delivered, then it will give you the tick mark. If it is not, then it will simply give you the error that the message is not delivered. If it is seen, if it is not seen, or the internet is closed, then it will give you only the tick. Okay, so the TCP is working over there, and TCP we are using if we want to send small amount of data. Okay, from where we need or where we are expecting the delay, we can say, right? Or we are expecting the reliable communication, and the communication will surely be acceptable or established. There we are using TCP. If I talk about the UDP, user datagram protocol, UDPs are not really reliable for communication, we can say. Now, if you are working on or using video calls, or you are doing video calls to your friends or someone, right? Now, if you are video calling, right now we are using the stream here, okay, on YouTube. This is again using a UDP protocol, network protocol, UDP protocol, user datagram protocol, because this is not giving you the error messages, or the connection is also not reliable. Why? Because the data which they are transmitting from my side to your side, that is a big amount of data. Okay, so that is why we are using UDP. Okay, UDP is fast, TCP is not just that fast with the UDP. Okay, IP, which means Internet Protocol, and DHCP, Dynamic Host Configuration Protocol, which we use for assigning the IP addresses to the system. Right? I can say that what I am talking about, CMD. Okay, here you will be able to see that. If I say what, which means I can say like if config. Okay. Oh, sorry, IP config. I was thinking that this is Linux. Okay. I'm using IP config. Then here you will be able to see it is giving you the IP address, my IP address. You are able to see up here. This is IP version 4, right? And this one is IP version 6. Where is that? This one is IP version 6, which is 32-bit, 8 bits. IP version 4 is using, and 32-bit the IP version 6 is using. Okay, so total 128-bit the IP version 6 is using, and 32-bit in total, which IP 4 is using. Okay, now this is the private IP address of my laptop, which is just connected, okay, by which I'm talking to you guys. Okay, now DHCP is working on dynamic host configuration protocol, which is helping routers to assign particular IP address to each and every devices which are connected to my router, or you can say your router. If multiple devices are connected, then how they are giving IP address, assigning the IP address, the private IP address to your PC on the basis of dynamic host configuration protocol. This is the technology which they are using to assign the private IP address to your devices, those who are connected with the Wi-Fi or router, you can say, right? And this is the gateway IP from where the traffic is coming inside and going outside. So this is the gateway, just like a gate from you are going outside from your home and coming inside your home. This gateway IP is working and watching all the traffic which are coming inside. And this is the private IP address. 192.168.1.2 is my device IP, the private IP. So if you search over the internet, then you won't be able to find this particular IP. I can show you, no problem. Right? Let me identify this one, okay, which is abuse IP. I'm going over here, right, and I'm putting my IP 192.168.1.2. The IP address, the same IP address which you were watching there, and I'm searching over here. Then was found in our database, right? You won't be able, if you are searching this here, it is also showing 1.2 is a private IP address, right? So the same thing I was telling you that this is the private IP address, and this is how we are exactly identifying. Okay, so I can simply make it possible, right? So you guys will be able to see this is private IP address. Okay, this is the subnet marks I have. This is the gateway IP. This is the IP version 6 of my PC. Okay, so this is how you can identify the things. All right, this is what exactly we are doing for this. Now, if I talk about, yeah, this was the DHCP. Okay, the IP addresses, IPv4 and IPv6. Now we have network security tools and technologies which we are using, which is somewhat like network security tools and technologies are essential for protecting network infrastructure and data from threats and vulnerabilities to be protected for any of the network layer. Okay. Now here the antiviruses are working. We are using VPN for encryption. We are using some SIEM tools for technologies for network security. We are using NSlookup. We are using data loss prevention, or we call it as DLP. Okay. Now DLP is somewhat like refers to the strategy, tools, and practices designed to ensure that sensitive data is not lost, misused, or accessed by unauthorized users. Okay, so that is called data loss prevention, and we are working on these particular measures of security. So we can say that network DLP, email DLP, data loss prevention for emails, data loss prevention for network, data loss prevention for your devices, data loss prevention for systems as well. Right, so they are working on data classification and policy enforcement. So we have to deploy the policies for DLP. Okay, Microsoft is also working on DLP, data loss prevention. They have different devices for that, the Defenders one, and they are working on DLP, data loss prevention. Now if I talk about these same tools, NSlookup, or some of the practicals I would like to show you. First of all, I will go ahead with SIEM, security information and event management. Okay, so that is somewhat like I can say it is on, okay, where yeah, so here it is, right? Now this one is the SolarWinds SIEM tool, which is security information and event management tool which we are using in security. Once we will start the bootcamp, the SOC bootcamp, then I will let you know that how exactly and the use of this SIEM tool. But as of now, you can see that this is the SIEM tool which we are using exactly to protect our data. And this is that SIEM tool which we are using to protect for the threats. And we are getting alerts and all the systems on these particular tools. Right? This is a SIEM tool. SolarWinds is the name. Okay, I can show that live event if you want to see. And if I say that for the, let's switch off the live one, and network event threats, you can see that this is the network event threat. Okay, so no events. Firewall events you can see up here. Okay, what type of firewall events you are able to see. IP addresses, deny. Okay, no connection has been established with one of the IPs from external IP addresses. Okay, over port number 443, which is HTTPS. Right, so this is the one, and this is the source address which was trying to create trying to create the access with this particular destination IP, you can say. These are the firewall events or a network events, you can say. Now, if I identify network events, right? So here you will be able to see unusual network events, unusual network traffic. This is how we are identifying the live events. Okay. Now all traffic you will be able to see up here, but in next form we will work on these logs, the network logs, how to understand these network logs. I will talk about this. But as of now, this is a SIEM tool which we are using for network security. And as you can see, multiple network tools, network logs we are already getting from different devices like firewall, IDS, IPS. Those logs they are sending to our SIEM tool, right? This is one of the example. Now, if I say NSlookup, then NSlookup is the tool which we are using for identifying that what exactly the servers are working, okay, what type of technologies they are using. And this is stands for name server lookup. The NSlookup stands for name server lookup. Okay, I will show the functionality of this NSlookup to you guys. Okay, so where is my command prompt? Okay, so command prompt is here. Okay, so how to write a NSlookup query over there to identify different type of resources for particular server or a DNS server. So one of the example I will run over here, right? So that is NSlookup. Okay, you need to write like this. Okay, then you just need to identify 8.8.8. Okay, the same DNS IP address of Google. If I'm running whatever type of data, it will give to us. The server name is unknown, so they are not identifying the server name. The address is, the MAC address is this. Somehow or somewhere Google is not providing you the exact data. That is why it is giving you the timeout here, right? The timeout for 2 seconds and unknown timeout, which means there is no error messages that is showing. Just a request has been timed out. Okay. Now, if I look for NSlookup for google.com directly, okay, then what it will give? So it is giving you the name server. Server name is google.com. Okay, belongs to google.com. The exact server name is unknown because they are not disclosing it just because of the security. Okay, and this is the physical address of Google server, and this is the logical address of Google server, but they are also changing these IPs after every 15 minutes. Okay, so whatever the public IP you can see up here, it will change after 15 minutes if you will try. Okay, so this is how we are identifying the IPs of any of the website. Okay, so this is the way by which we can identify the IP addresses of any of the server or any of the website if you have. Right. Then we have NS lookup. Lookup, right? Then I'm identifying the type is equals to. Then I need to identify the mail exchange, which type of mail exchange services the Google is using. Okay, so I will write it as google.com. This is just an example. I'm applying google.com. If you want to change, or you can use any other URL except google.com, so you can apply those URLs as well and simply go ahead. Now here you will be able to see that NSlookup hyphen type is equals to MX, which means mail exchange servers data it will give you, and for google.com if they are using. So again, it is showing server name as unknown, okay, because they are not disclosing the name. This is the physical address you can see. DNS request timeout after 2 seconds. And not google.com is also using the Google mail exchange servers itself, because we already know that they are using the Gmail. Okay, so Gmail is using the google.com, and they are using the simple mail transferring protocol as google.com. So this is the DNS of that Google exchange servers. And what are the IPs they are using for exchanging your email addresses? What type of IP address you can identify, right? And this is the IPv6 address of those particular servers on which your email is bouncing from one system to another, and after that delivering to the participant or the recipient, you can say. One thing to identify the mail exchange servers, then I can say the same query Might be possible it will work, because if Google has not blocked us, right? If you are running so many NSlookup queries, might be possible Google can block us. Oh, luckily it has not blocked us. So you can see the multiple DNS responsible mail address. You can see it here. Google.com is using the name server as ns2google.com. This is the IP addresses, and this is the physical IP address. This is the IPv6 logical address, which you can see up here. Now I would like to tell you about SOA. SOA is lookup for a SOA record, start of authority, okay, provides the information about the domain, what type of domain the Google is using, or any URL if you're going to use, they are using, right? The email address of the domain admin and the domain serial number they are giving you. As you can see, the name server you are already giving, and the DNS address is, the list is in front of you guys. Okay. Now, if I say one more, if you want to get the hardware information of this Google servers, then you need to identify hinfo. Okay. Then here, this will provide you the hardware information, okay, about the host, what type of host they are using. It provided details about the operating systems as well, what type of operating system the particular host is using, the Google host is using. So this is how the attackers are exactly gathering the data about the host on which they are trying to attack. Okay, so this is how they are identifying which type of OS they are using, the host or the servers are using, so that they can mark the vulnerabilities, what type of vulnerability that particular operating system has, and accordingly they can attack over the system, over the victim. Okay, so this is the reconnaissance part which we are doing over here. So I think the Google has blocked our command. Let's try once again if it is us the, yeah, here. Okay, so this is google.com. The primary name server is ns1. Responsible mail address is dnsadmin google.com. This is the serial number, but it is not revealing the much data which is not required to reveal for this particular NSlookup command, because this is the security which Google is trying. Okay, so that is why it is not revealing, but again it is showing you that whether the traffic is went or out, but it is not relieving such type of system configuration or hardware configuration or operating system configurations to you guys. Okay, so this is the simple thing which we are trying to identifying and doing over there. All right, now coming to the another part, NSlookup has been done. I would like to show one more interesting thing to you guys, from where I was talking about the packets. Okay, now here on your screens, which is Wireshark is a tool to monitor the network, large networks, right? So Wireshark has been used by large organizations as well to monitor their traffic. Okay, so if I'm clicking on router, my router is connected. Okay, so I'm clicking, double clicking on this, then this is giving you the traffic here. This is going live. Okay, if I'm increasing the size, right, once more. Okay, so you will be able to see that how it is exactly taking the traffic, and how my router is communicating with different devices and get the data and transferring the data, transmission of data, communication between all of those. Okay, so this is giving you the exact, as you can see, the destination, it is communicating with you guys. Why this is going this fast? Because right now I am into this stream, and it is, you can see that it is communicating with the same subnet of IP addresses, the destination IP address you can see up here. And here I can see that UDP protocol, you can see most of the time. As I told you, I am into the stream. Stream needs a large amount of data, so that is why you can see the UDP data up here. Okay, so if I'm stopping it, right, so here you can see that the UDP data you will be able to see identifying this one. Okay. Now this is how we are exactly working over the Wireshark. The communication we can see to use Wireshark networks. Okay, now destination, this is the physical address of that IPv4 they are using. Okay, I'm trying here, then it will give you the what type of flags, what type of UDP communication they are using is 128. The IP addresses, which IP address they are communicating with. So I can show you, no problem with that. This IP address belongs to this one. Okay, now I'm going here, abuse IPDB. Okay, to check the IP addresses of all these systems. Right, clicking on this, marking up here. Right, now if I say this one, okay, and what is the IP address? 35.232.112.161. Okay, this IP address belongs to Google. Okay, so my device is communicating with the Google servers and transmitting some type of data. Why? Because I was transferring the data. Just a few minutes ago, we were trying to NSlookup. Okay, and that NSlookup are going into this, right? The amount of data which they are sending towards the Google, and the port which they are using, which is an external port. Here you will be able to see. Right, and this is how exactly we are identifying the data, what type of data they are using, and this is the encryption form you can see. Okay, now if I want to see the topologies, not the topologies, I can see the statistics. Okay, protocol hierarchy, what type of protocols this is using. So you will be able to see the version 6 protocol it is using, Ethernet it is using, UDP protocol it is using, TCP protocol it is using, IPv4 it is using, UDP again inside the IPv4 it is using, and TCP again it is using for dynamic host configuration protocol. It is also, you can see up here. All right, now if I want to apply this filter, selected, now what type of data it is transferring to which network. Now you will be able to identify that my DHCP server, which is there on Wi-Fi. Now what type of data it is giving to us. Now I will follow the stream. Will show you the exact amount of data that what I am doing. So the Android DHCP it has been applied, which means one Android device just connected with my Wi-Fi. So on basis of that, this is showing the Android DHCP. It is right now working and applying the IP address to all of those. Right. If I want to check the UDP stream again, okay, so I will go statics, check for the UDP. Okay, apply filter, selected one. So it will give you the idea about the UDP datagram. Now, if I want to open this, follow the stream. Follow the stream, UDP stream. Okay. Now here you will be able to understand. This is how it is giving you the exact data. This is the TCP addresses on which it is communicating. The Android version 2 it is using. Okay, and the remote connection it is creating up here, right? And yeah, this type of communication it is. Okay, so my Android TV is also connected with this particular Wi-Fi, and it is communicating, sending the data and receiving data. You can see up here type of devices, Android TV. Okay, so we are using TV here. So which type of data it is sending and receiving, and which exact IP addresses it is connected with. So you can see up here, right? So these type of data we can understand that what of things they are communicating with, and how our traffic. Basically, you can see the traffic, okay, which is going from outside to inside. Okay, this is a Wireshark tool. Okay, whenever I want to see that which device is directly communicating at what kind of type of servers, whether it is transmitting the data, the unknown data to some other servers or not, then this is how I can see, right? So this is the small example which I gave you for Wireshark. This is really we are using. Okay, so now I can close the Wireshark. Okay, if it is done, quit without saving. Now let's come to one of the part which is remaining. Okay, the web traffic audit, TCP traffic audit, TCP port scan, and ICMP. The network logs we will work on. Okay, now I can show you the network traffic and I'll show you the exact communication with the help of SIEM tools. The network logs we are getting into our SIEM tool. So if I talk about firewall events. Then which type of firewall events which we are getting? TCP traffic audit. Okay. Destination IP, the traffic has been denied from this particular source. If I get this source, copy this source, and going up here, right? This is communicating with Google LLC again. Okay, so this is how you can identify. This is also giving the BREP traffic, TCP traffic, UDP traffic, right? One thing. Then if I search for network, right? So which type of network traffic it is giving, remote procedure, TCP port scan. If somebody is trying to scan your ports, then this is what the network traffic will look like. From this particular IP addresses, you are receiving a port scan activities inside your network. So this is how exactly we are really working in the live environment of security. Okay, we are getting multiple amount of data from network devices, and this is how it is looking like. Right? I just show you the same which you will be able to see up there. Right? So network logs are crucial for monitoring. If you are working into the SOC, then they are crucial for monitoring, analyzing and securing the network environment. They provide a record of network activity, right? The activity which you can see up here, which can be used for troubleshooting, performance monitoring, security analysis, and compliance. Okay, so this was it, guys, for today. Okay, and this is how exactly we are working in the live environment. Whatever the tools I show you, whatever the things I show you, the topologies, the tool, the SolarWinds tool I show you, that this is how we are exactly working real time in security environment. Okay, right. So I would like to thank you all for joining today's session, and we'll meet you tomorrow.